All right, so let's just go ahead and go through an example. A spacecraft can attain a stable orbit 300 kilometers above Earth if it reaches a velocity of 7.7 kilometers per second. All right, so that is key. So in order for a rocket to attain a stable orbit, it has to have 7.7 kilometers per second as its velocity. All right, then they go on to give us what the formula is for a rocket's maximum velocity right here, where it says that v is equal to negative 0.0098 t plus c times ln of the r. Right, then it tells us that this t represents the seconds that it takes. Right, so it represents the booster fire rockets for t seconds. So it represents how much time the booster rocket fires. The c here represents the velocity of the exhaust. And then the r represents the ratio of the mass of the rocket filled with fuel to its mass without fuel. All right, so it tells us what each of our variables represent. And then down here it says, suppose the rocket shown in the photo has a mass ratio of 25. So that means that this 25 is equal to r. So we can say r is equal to 25. Then it says it has a firing time of 100 seconds. So we knew that firing time represent our t, so we can say t is equal to 100. And then it says it has an exhaust velocity as shown. So it gives us an exhaust velocity here in our picture. So it says it's 2.8 kilometers per second. So it means that we know our c is equal to 2.8. So now that we know what all of our variables are, our t, our r, and our c, we can go ahead and plug them into our velocity formula. So v is equal to negative 0.0098 times 100, because our t, plus 2.8, that's our c, times ln of r, which is 25. All right, so now we don't have any variables in this equation, so we can literally just go ahead and plug this into a calculator. So we will get v is equal to negative 0.98 plus 2.8 times our ln of 25, which is equal to approximately 3.219. So then we'll multiply that by 2.8, and that's going to approximately be equal to, so we'll have v is equal to negative 0.98 plus 9.013. And then we will combine here, we will combine our numbers, and we will get that our velocity is equal to approximately 8.03. So it means it's approximately equal to 8.03 kilometers per second. And since 8.03 is greater than the 7.7 that's needed in order to attain a stable orbit, that means that this spacecraft can attain a stable orbit 300 kilometers above Earth. So we would say yes as our final answer. All right, now that's it for this video. That's it for this section.